Howdy folks, and welcome to day 2 of Java. So today we're going to be focusing on some more syntax and some other basic stuff to get your programs running and to get you to learn a little more about Java. So in the previous video we discussed basics like variable names and ints and some other basic ideas of how Java works, how it's compiled, how everything kind of runs behind the scenes. But just a very basic overview of how Java works. And now we're going to actually get into a little bit more on writing code and getting more comfortable with the Java environment itself. So to do that, we'll start off with some answers from the last video. So in the previous video, I had tasked you with looking at some or creating some program that would add two numbers together, 27 and 33, and store that in an age variable, and then you would make a print that would say my age currently is, give that age, and then of course say I'm not a young man anymore, because of course you'd be 60 at that point, so I suppose that wouldn't be considered young in today's society. But anyways, so there's a few different ways to do it. As always, Java or many languages, you can write programs in many different ways. But this is just one way that I did it. And I just stored those two numbers in different variable names, num1 and num2, and then added those together in the age, as you can see. And then I used two system out print lines. And the beauty of the system out print line is that it uses a carriage return, or an enter as you might consider it in other programs. So it will print, or it will create a new line after it prints something. So that way the next line that's printed is not going to print on the same line as the current stuff. So my age currently is will print on one line. The next line will say I'm not a young man anymore. And you'll see that example here in the answer here. And I just ran this in a terminal in Ubuntu. You might have heard of it as a command line in Windows, but basically I ran the program using Java, and we'll get more into that later. And that was the results for it. So there's what it should look like, and hopefully that kind of helps a little bit if you had any troubles. So moving on, I wanted to get into today some more specifics on what Java specifically is going to need you to do in order to kind of get some runnable programs here. And that deals with this whole class business. And Java always begins with class and then some class name, and then you have these curly braces, which is where all the kind of bulk of the code will go. And that will store all the kind of stuff that you want to do for the program. Now, classes, you might have heard of classes and objects in object-oriented programming. However, we're not going to get into kind of that specific stuff yet, but we do need to get into some basic framing stuff and get the basic framework of Java set up so that we can run some programs instead of kind of theoretically run them. And they can be public and private, these classes. And again, that's not super important right now because we're not going to worry about that. That kind of deals more with some class and object stuff, but we'll focus on those details later. For now, we'll just remember that every Java program that we'll write for now will say public class, we'll give it some name, we'll put in these curly braces, and then inside those curly braces, we're going to have this thing that says public static void main, and inside the parentheses for that, we're going to say string args. And you see those little square brackets there. And we'll get into more details on that too. But basically every program that you've run on your computer, or should be pretty much every one of them, has this main method, if they're an object-oriented language, that is the main point of execution for every program. So it's pretty cool that you also will be doing the same thing. So your program will run the same way as many, many other programs that you've used before have. So that's kind of the linking factor between everything, and that main method is where the execution always starts. So we always got to have that, and that's where we're going to be focusing a lot of our time in for the next little while here. So as you can see, I've written down there too that classes and main are crucial to running Java programs. You always got to have these bad boys. So moving on from that and getting to more specifics and basics, we're going to go over a little bit of some of the data types in Java. So in the previous video, we discussed the int and what the int could do. However, the int has a bigger family, and there's a lot of different family members of all shapes and sizes in there. And you can see some of them here. So we have bytes, shorts, ints, longs, floats, doubles. And that's just a few of the many data types that are supported in Java. But these are numeric data types, and you can see the range of how far they span and how big they are in terms of memory. So I wrote at the top there that there's 8 bits in a byte, because that's important to remember, because you may see things where they'll say this thing it's a 32-bit data type, like a float or an int. But some people might say it's also a 4-byte data type. Well, those are the same thing. It's just two ways of referring to the same thing. So there's always 8 bits in a byte. That's how you can remember it. And if you ever see so many bits, divide that number by 8, and that's how many bytes that something will have. So you can see as the list increases there, and you get into 64-bit or 8-byte data types, like the double, we've got some extremely large numbers that we're dealing with there. So in the case of writing a program, if you're thinking in terms of memory, you might use something like a byte for an age, but you might use something like a double for the size of the known universe or something like that. But typically we don't worry too much about memory in most cases. However, if you're going down a machine architecture path or something like that, I suppose you may have to worry about that, but that's all kind of worry for some other time. So just remember that these are different data types. And the other important takeaway is that ints, I don't know if I mentioned before, but ints are whole numbers, and floats and doubles are decimal values. So if we ever want to do some division and we're going to get some decimal back, we want to use a float or a double. Now, if we wanted to get a whole number back, then we would use the int, because the int does not ever return a decimal value. So that's just a little bit on some of the data types of Java. So hopefully that kind of clears things up a little bit and kind of broadens the horizon of what Java has to offer. And moving along with some of the numeric stuff, we can't help but talk a little bit about math. And Java has what's called a math library. And libraries just allow you to do kind of cool stuff that Java has or other people have implemented that saves us some time from having to implement it ourselves. And Java has a great math library that allows us to do all kinds of different operations, like a square root or the power. And you can see I've listed those there, and I've used the double in those cases. But of course, you can use all kinds of different data types. And then we've got the main math methods that are supported. And I mentioned this in the previous video, that addition was supported. However, we have subtraction, multiplication, and division joining along for the ride. And then we have one more little interesting guy that you might see that might be a little different than what you've expected. And that is the mod operator. And this guy is represented with the little percent sign. And he does something very interesting, which he returns the remainder of something. So, as we've mentioned before, ints don't handle decimals. So if you do something like 17 divided by 5 as an int, you would get 3 as the result. And you would expect 3.4 in a common mathematical operation, and your head's saying, well, what's going on? I mean, what's that? There's a remainder, right? Well, you'd be right in that assumption. And that remainder is that 2, right? Because the highest number that can be divided by 17, that we can get something, we could do 15 divided by 3, but we have 2 left over. So if we do 17 mod 5, we get a 2, because 17 divided by 5 has a remainder of 2. And this is great for determining how to give change back to someone. So in the case that you want to give change back to somebody when they've handed you a $20 bill, well, if you're dealing with quarters and pennies and nickels, it might be the case that you would come across something where you have a third of a quarter to give back to somebody. Well, we can't really have a third of a quarter because we have no set of money that is, or no coin that's denominated to be that specific size. Nor can we cut up a quarter and say, well, this is only a third of a quarter, so we'll just use that. So we want to pass that operation down to a smaller value and split it up into pennies and dimes and nickels. So that's what we use mod for. Mod's great for determining that remainder that we can use after using, if we have 25 cents or 10 cents. It can pass that down, and we can continue to do operations and realize, hey, we can't use 2.5 quarters. We got to use only 2 quarters if that's all it can support. So that's kind of a little bit on the mod operator, and hopefully that clears things up there. But the mod operator you'll see used a lot in Java programming, so it's good to get familiar with that. So moving on to some mundane tasks. And that is that programs need to do the same tasks over and over and over. And when that happens, it can be kind of a bore to write the same stuff over and over again, or to have to get the same information over and over again. So, for example, if we're thinking in the case of, I have a room of 20 people and I want to get the ages of everybody in there. Well, I don't really want to write 20 different variables that have 20 different ages, and I don't want to go around the room and say, what's your age, what's your age, what's your age? I just want to have some way where I can kind of tell everybody, I can get everybody's age just by having them fill out some form or having them fill out something in my program. And Java supports this. However, the whole business is the scanner class, and that's kind of more difficult than we'd really want to get into at this point. So we're going to bypass that for the time being using a great little program called TextIO by David Eck. And I've included a link at the description of this video that has the source code for this. And all you have to do is just copy this and put it into your Java program, or just save it as a Java file, textio.java, and save it in some directory that your Java program is in. So if you have your Java program in documents, then you want to also put TextIO in the documents. And then when you compile, it can use that TextIO stuff. So that's what we're going to use for our purposes, just to make life a little easier and to not have to worry about the scanner class at this point, but still get information from users. So that can be referenced using textio.get and then something like an int or a double or all kinds of different data types. And you'll see that the library that Eck has put into TextIO that of all the different stuff that you can use is pretty vast and wide. So it's awesome, and we'll use that for our purposes. And to kind of get into a little more on how that works, we'll look at some sample program that has no user input. So this shucks as a developer, because we have to figure out, in this case, we have Gary, Alex, and Neil's age. Well, we have to figure out what their ages are, and then we're going to put it into our program. And that's kind of a bummer, because we don't really want to do that. It would be much easier if we could just hand something to these guys and say, hey, enter in your age, and then we're going to do stuff with it. And you can see here, that's not the case. So we're going to try to remedy that in another program that we'll look at here. So this one's Age Business Bad, but we'll look at Age Business Better that actually gets some input so we can actually figure out what Gary, Alex, and Neil's ages are, and then do stuff with that later on in those system out print lines. So this is great because now we can hand them the program and ask them to put the information in, and then we can do stuff with the information that they put in later on in our program, and we never need to be there. We could ask them to run this program, give them the laptop or whatever it's running on. We could go out and get a drink and come back, and the program's still running just perfectly, and all is good in the world because our program was able to do information with the stuff that they had entered in. So let's see an example of those two programs that we've looked at run on the terminal. And it might be a little blurry here. I just tried to make it bigger so you guys can see. But as you can see, when I run the Age Business Bad program, we get this, Gary's 65, Alex is 64, Neil is 66. We are the priests. And that's pretty much all that we do with it at this point. However, when we run the Age Business Better program, we're going to prompt them for ages for Gary, Alex, and Neil. They're going to give us those ages, and then again, we're going to do the same stuff that we did as above, but now we're going to use those ages that they gave us. So you can see that our program can still run and still do stuff even after they've entered in some input. So we don't need to be there to always handle the input. And that's the beauty of programs, is the whole input-output business. And you'll see, as seen here, there is some great examples of that. So that's why TextIO is so great. It allows us to kind of avoid having to go in and do that for ourselves. So you're probably confused here, or you might think, well, that's weird. Like, how did he get this whole thing running with this Java age? But what is that all about? Well, let's get into that, because that's an important part of this. And that is compiling and creating Java files. So now we're getting into the real course of things, and we're actually getting into the real business of how Java works and getting in the down and dirty of it. And if we're going to do that, then we're going to need to learn how to compile a file and run it. And that's what we're going to take a look at right now. So we've used class and main in some of our programs that we've looked at. And we'll see in the program that I'm going to show as an example how that works. So the first thing that we want to do is compile the file. And to do that, we're going to say javac, give the file name, and then .java, because we always save our files, those human readable files that is, as .java files. And then javac is going to do that whole nasty business of converting it to a .class file, and then that's going to be what's ultimately going to be run on the JVM, and it's going to do the whole program for us. Anyways, that javac is what's going to take care of all that. And then we want to run that file. We're just going to say Java and then give it the file name. And we're going to exclude that .java part because we don't need that anymore. So let's take a look at how the heck this works. And an example is perhaps the best way to do that. So we're going to go into my VM, my trusty VM here, virtual machine, which is running Ubuntu. And we're going to take a look at some file that I have here. And I've called it input and compile. And as you see, don't worry about this business here. But you can see down here, I've written some code. And we have this input and compile. And then we have this in the main method. We have all kinds of input that we're going to get from the user. And then we're going to multiply all the numbers that they gave us as input and print the result. So in order to get this to work, we're going to need to compile this file. It hasn't been compiled yet. So if we tried to run it right now, we would say Java and then input and compile. But we're going to have a nasty error because it hasn't actually been compiled yet. We're just trying to run this file as it was. And you can see it can't load a main class input and compile. So we need to create that. So now, we're just going to go ahead and compile this. So what we're going to do is we're going to say javac, and then we're going to say input, and then we'll press tab, and that will bring up the .java, the rest of the file. But that's just a nice little shortcut, so you don't have to write the whole file name out every time. But once we do that, we'll press enter. Everything goes smoothly, and then we'll try running it again using that similar command that we gave. And you'll see we'll ask for a number. So let's give it, I don't know, 7. It wants another number. Okay, let's give it 5. One more, we'll give it 9. And then a big number, like 4 digits. Okay, let's give it 1, 2, 3, 4. Well, it multiplies it right before the eyes, and look at that. We get some really big number as a result of multiplying all those numbers together. And if you'd like to fact check, make sure that ran correctly, go grab the calculator or bring out the multiplication by hand and make sure everything runs smoothly, but that should be the answer that you get. But there you can see a simple program that I've written, the compilation of the program, and then the running of the program on the terminal there, and we get to do some cool stuff using the input that I gave it. And if we run it again and give it some other stuff, and maybe we'll give it a 6 this time, and a 3, and 8, and then we'll give it 4, 1, 2, 2, we'll get some other number, and an even bigger number because we're using 4,000 instead of 1,000. So that's how you kind of run programs in Java, or at least running them on the command line, which is where we'll be running a lot of our programs, just for the purpose of avoiding having to deal with interfaces and stuff and user interfaces and all that. We'll focus on that at some other time, but for now we'll just do terminal related stuff, so that way we can still see really cool stuff happening and still do input output, and you can kind of see we get to run some awesome programs there. So that's just a little bit on compiling and running your Java programs. So now getting back to the rest of the presentation business, we've got some stuff for you guys to try. So the first thing to do is create a Java file that will mod two numbers and store that in a variable. Then print that variable. Then what we want to do is multiply that modded number by 3 and then print the result of that multiplication. So that's one program to do, and it should be simple enough as what you've seen in the previous stuff here. And then the other thing would be to create a Java file that takes two integers as input and then divide those numbers and print the result. So should be pretty basic programs, but it will help in getting that understanding and make sure you're following along with kind of what we gone over here. And don't forget to use that TextIO business that we've discussed to write those programs, and make sure that it's in the same directory, like I said, or in the same folder as the program that you've written. And of course you can use the editor of your choice. We can get into editors a little later, but for now just kind of use some editor that you want to use. There's great ones out there: Dr. Java, Eclipse, Visual Studio Code, all kinds of different stuff to run Java or create Java programs. There's even online stuff that you can use. But anyways, feel free to use whatever to write those programs and try running them and making sure that you can run them in the terminal or command line and that everything goes smoothly. So then finally, some review here. So review number 1, what does every Java program contain? We mentioned it earlier. What's the crucial part of Java? What do we need? And what will help us run those programs, or our program? Then number 2, how can I read input from a user? So we'd mentioned scanner business and how we wouldn't really get into the specifics of that. But what was that other thing that we were looking at that we were going to use that would allow us to get some input? And then how would you compile and run a Java program? So what did we do in the previous step there when I went into my virtual machine? And then finally, are you enjoying it? So I know it's only day 2, and we've just seen some very basic stuff, but I hope you've been enjoying it so far, or have kind of enjoying the material. And if not, try to stick with it and see that there's all kinds of stuff that you can do in Java and programming in general. So you might find something that's really enjoyable and you might really come to like. So stick with it. You can definitely do it. It's great and it's very easy to get into. So don't be afraid of it and just keep working at it if you're confused, and be sure to leave comments if there's any confusion. But just keep working along on it. You can definitely do it, and I hope you will find some enjoyment out of it in the future if you're not enjoying it now, whether it be with my videos or perhaps with somebody else's videos. But anyways, that's it for today. As you can see, it is Christmas Eve, so if you're watching it on such a day as today, then I wish you a Merry Christmas Eve. But anyways, I will see you guys in the next video, and take care, folks.